Hello and welcome to another episode of On Air with Daikin. I'm your host, Matteo Dall'Ombra, and today I'm joined by a long-time collaborator of ours, Daikin. I have the pleasure of being joined by Jake Matthews, Operation Manager for A-Gas UK. Welcome, Jake.
Thanks, Matteo.
Glad you could make the trip, and hopefully the journey wasn't too bad.
Slight delay on the train, but
It's all right.
Yeah,
This day is the least.
yeah.
It's the worst that can happen.
Yeah. You expect it now these days. So,
But no, really, thanks for joining us today. And it's always great to have a chat with you. And as I said, we've been collaborating for quite a while. But today, really, one of the main reasons for having you here is to try and delve a bit deeper into the magical, mystical world of refrigerants and everything that is associated with them. Because both our companies are heavily involved, one way or another, in the world of refrigerants. So speaking of that, before we actually go down that specific rabbit hole, I was wondering if you can give our listeners a bit more of a background in terms of who A-Gas is, what do you do at A-Gas, so that we can just give a bit of a better context.
yeah, that's great. So, I've worked for A-Gas joined in 2017, so 8 years I've been with A-Gas. I've got an environmental science background, so I studied environmental science at uni with the hope of going into the renewables sector.
Nice.
Stumbled across A-Gas, and obviously refrigerants have a direct correlation to the environment. So
Massive.
yeah,
And I'm sure we'll talk plenty about it in just a second.
So I got very interested and joined A-Gas in the environmental services department.
Okay.
So great team there. So they basically introduced me to all the equipment that we use. Obviously, we've never handled refrigerant before.
Mm-hmm.
Most people haven't got a clue about refrigerant.
Yeah, which is also why I really wanted to have this conversation to maybe try and remove some of the myths as well from the refrigerant, because it is kind of like a substance that we kind of all know that it exists, but what it actually does, how it actually works, sometimes a bit of a black box mixer. But sorry, go on.
No, that's fine, 100%. So, yeah, most people start out, they haven't got a clue. Yeah, most people are scared of refrigerant. Yeah, it could burn you, asphyxiate you, high pressure.
We don't talk about all of that.
Yeah. So a lot of people, they think, oh, do you know what I mean? Safely handling refrigerant seems like a massive task for a lot of people to undertake, but it's not. Once you get comfortable handling it and everything's in a controlled environment, you become a lot more confident. You start to understand the different blends, different pressures.
I guess it's like with everything else in life, like the more you can comfortable with something, the more you know how to deal with it.
Yeah.
It just becomes another thing that we work with, like many other tools.
Yeah, it's a shame as well, the industry, not many people understand that refrigerant in itself, so the HVAC industry is a great industry to come into, to be involved with. Like, throughout school, there's no mention of the HVAC industry. Oh, you could be a plumber, you could be an electrician, you could be a lawyer. Right. They never mention.
It's great that we already pick a tangent.
Yeah, I know. Yeah, we have.
But you're absolutely right.
We
do quite a lot of work as well with colleges to try and promote the idea of this is a great industry to work with, and these are all the things that you can get involved with.
It crosses over as well.
Oh yeah,
different industries.
Massive.
Even when I changed my kitchen sink the other day, the fittings that I needed for the kitchen sink to repair the tap was leaking. I replaced it, and the fittings were all crossed over to the refrigerant.
Right.
Yeah. So that was just like, my wife was like, "How do you know that?" I'm like, I'm a plumber. Yeah. But anyway, back to A-Gas.
Yes.
So,
because you're based in Bristol, right?
Based in Bristol, yeah. So that's the UK's main site where we process all refrigerant gas.
Right.
So the bread and butter of A-Gas is wholesale supplier of refrigerant.
Mm-hmm.
So we are one of the leading manufacturers and downpackers of refrigerant to the wholesale market. The caveat. The other sector that we're in is obviously reclaiming used refrigerant.
Yep.
So the technology that we've got in the UK and now globally is we are able to take used refrigerant from the market. It could be any type of refrigerant, CFCs, HFCs, HFOs.
All those wonderful acronyms that are unpronounceable, and we'll leave it at those three letters for now.
Yeah, so CFCs now mostly, when I first started, we've seen a lot of R22, some R12, R11. They're pretty much now, you don't see it very often now at all.
Right.
So the industry has moved on from those high ODP refrigerants, and obviously they brought in the HFCs.
ODP, sorry?
Ozone depleting potential.
Good.
So
again, just for the benefit of the audience, because
so they have been fully phased out.
Yep.
They brought in HFCs, and they basically have a different problem in terms of their GWP. So they've got a ODP of 0, but their GWP is relatively high.
And what is GWP?
So GWP is the equivalent of 1 kilogram CO2.
Yeah.
So say 404, for instance, releasing 1 kilogram CO2 into the atmosphere would be, if you release the same amount, 1 kilogram of 404, it's the same as 4,000 of that 1 molecule of CO2.
Right. So essentially, global warming potential representing how X many times worse a refrigerant would be compared to CO2 if it was just to be uncontrollably released into the atmosphere, which I guess is also why there's so much pressure and focus on making sure that that doesn't happen at the end of the day.
Yeah, so if there's a real-time sort of quantitative, to make it more quantitative, is 1 kilogram of 404 is the same as 1 vehicle driving 10,000 miles.
That's quite a lot of miles.
Yeah, so you think if you vent off 500-600 kilos of this gas.
Of course. Yeah, so not a great thing. Not a great thing to do.
So obviously the Environmental Agency is enforcing.
Yeah.
There's obviously rules and legislation in place with F-gas.
Of course. You did mention that one of the things that sort of distinguish you as in A-Gas as a company compared to other is the capacity and the ability of handling refrigerant and reclaiming and recycling. And I guess full disclosure in terms of also one of the reasons why we're here, Daikin and A-Gas, they are engaged in sort of a unique partnership in the UK market for sure, where we've been very happy as Daikin to leverage that ability for you to reclaim the refrigerant. We were chatting on the way here to the studio. We think that we figured it out. So we started in 2019 with the actual sort of official partnership when it was launched. It went for a couple of names, but now you would hear it as a Reclaim with Confidence, being sort of the headline name for the service. Want to give us a bit of a background on how that works?
Yeah. So, as I said, we supply gas to the market. We also reclaim gas from the market. So the partnership we got with Daikin, obviously we are there to facilitate gas reclamation from Daikin systems, Daikin specific systems. We also offer this service to non-Daikin customers. But basically the gist of the service offering we're giving to the market is we can recover gas safely, quickly, efficiently, save the contractor time, money. So if they've got 10, 15 systems on a roof, they have to get cylinders. They've got to get those cylinders up to the roof. They've got to get someone then to sit there for a couple of days, potentially, recovering that gas. Then they've got to make sure they've got all the gas accounted for, get it back down, and then they need to get it collected or drop it off wherever they need to get rid of it. So it's a big headache for contractors to do it themselves. So
which is how we got to creating that partnership to begin with, because essentially, and I mean, I guess when we started, it wasn't maybe as big of a thing as it is now in terms of, let's say, the general public opinion of what we should be doing with the refrigerant. We were certainly, from a point of view of the offering, I guess you could say we were a bit ahead of the curve in a certain sense, at least from what the manufacturer decided to do with their own customers. But we certainly started to get those questions where, well, what do I do? Like, I need to decommission the system. It's holding plenty of refrigerant. What do I do with it? And that's when we essentially started looking around and said, how do we make it as easy as possible for our customer to do the right thing at the end of the day? Because we can dress it up as much as we like, but fundamentally the core objective is making sure that they do the right thing in terms of making sure that the refrigerant, which we'll talk about more in a second, but it is a great resource, it's an invaluable resource. Probably you could almost consider as having an infinite shelf life to a certain degree. So it should also be very easy to keep it in circulation and keep it used and recycling and reusing over and over again. And certainly at Daikin, again, we deal with a huge amount of refrigerant on a yearly basis, not just in the UK, but across Europe. So for us, it was also important of how do we find a way to work with our customer, with our partners, offering essentially something that only a company of the stature of Daikin is able to, with the infrastructure, with the resources, with the partnership. And it's been absolutely great over these years. There's only positive comments coming from our customers, coming from the rest of the industry, and looking really forward to continue that partnership into the future.
Well, you say you've removed a hurdle for a lot of people, a lot of customers.
That's it.
Yeah, you've literally just knocked that down. There we go. We've got a service now that can come and safely recover that gas for you.
Yes. It's fundamentally, at the end of the day, one of the other big mantra that we try and live by is how do we make it as easy as possible for our partner to work with us to achieve a common goal.
Yeah.
The goals might change, in this case refrigerant, but still the same mentality of work with us, and it's going to be easier for you moving forward.
The other thing you're doing as well, when you're using all your units, all your new systems, all reclaim.
Well, that's a good point to make, I guess, and thanks for throwing the ball in in my corner in a sense. Well, it's certainly becoming more and more commonplace. So now R14A is the one that we've pretty much 99% completely phased out in terms of using virgin gas, and we only use reclaimed refrigerant, which kind of continues the theme of why sort of Daikin and A-Gas work together, because we don't just work together at UK level, but we also work together at European level, and so it's continuing that message of the two companies working together in partnership to continue to achieve the same goal. But yeah, so R14A, as I said, virgin gas pretty much completely now phased out. So all the units that we still supply, which are still quite a few, they all come out of the factory with 100% reclaimed refrigerant in them. And actually, we started still in a bit of a smaller fashion, but we started with R32 as well. Specifically, there are a couple of chillers model that come out of our factories in Italy. They are using reclaimed R32 at the moment. I mean, I guess the trajectory is very much set in terms of us wanting to do it more and to do it anyway. It's just a case of the refrigerant being, quote unquote, slightly newer in terms of the adoptions at larger scales, so that we don't really have the same reliable stream of R32 that comes back into the likes of A-Gas to be able to be processed and reused again. But as I said, the trajectory is very much set that we should just continue going in the direction of using more and more reclaimed refrigerant as much as we can.
So this is the same with A-Gas. This is what we're trying to do here. There's roughly, I think, 5 billion systems in the world that have
That's
a charge have legacy refrigerant charge.
Right.
So all that gas has to go somewhere. You don't want to go in the atmosphere.
Nope.
Every kilogram that goes in that atmosphere, we then need to replace. So you may as well, because the resource going into making new refrigerants is massive. Yeah. So if we can recover all that refrigerant, clean it, bring it back into spec, so it's sufficient as brand new virgin refrigerant, it just makes sense to do that.
Yeah, absolutely.
And again, it's a system with that phase out. You can't just say we're going to cut these particular gases. It has to be a gradual phase out. And you say, we were chatting earlier, and if a company, say, in the last 5 years has just had HFC, large systems installed with HFC refrigerant, they've spent a lot of money to get that installed. They need to have access to the refrigerant that's needed to run that system efficiently. Reclaimed refrigerant also comes with the benefit of no quota. Mm-hmm. So in terms of cost, so again, transition to these new refrigerants, you've got the flammable aspect.
Now let's explore a bit more on the quota, because it's I think it's going to be even more important into the near future to have a better understanding of what we sort of manufacture, or let's say people that work within the HVAC industry refer with quota, because I think it's a name that sometimes gets thrown around similar to some of the acronyms, but I think it's important to make sure that everyone understands exactly what we refer to. So what happened at European Union level effectively was that the various legislators, they decided to try and address in a very sort of practical and concrete way the impact of refrigerant on the environment, fundamentally. And one of the measures that they decided to implement was the idea of saying, well, if we can somehow limit the production on a yearly basis and what can go in the market in terms of brand new manufacturing of refrigerants, then in theory, there's less that can potentially escape from systems, and therefore things might not get worse, but things might actually get better. So when we talk about phase out and when we talk about quota, what we're talking about is essentially an artificial limit that was placed on the market, where they said, well, every year you can only manufacture or import from outside the European bloc a certain amount of F-gas products, which, by the way, and you know better than we do, is everything is not just air conditioning system. It's like any, as we were saying, there's refrigerant everywhere. So
yeah,
all of those.
So anything with a GWP is basically subject to quota.
Exactly. And of course, what you do is that you do a calculation based on what is the global warming potential of each refrigerant, how much you want to manufacture or to import, and that tells you what is going to be the impact on the quota. So how much of that quota you're going to use by deciding to, again, manufacture or import that specific amount. But the good thing of this phase down, which again is progressively, and it started in 2015, and it's sort of looking at 2050 as a sort of ultimate horizon. But I guess the good thing, and where we again go back to us maybe being a bit more ahead of the curve, is the fact that on top of this curve, which again only sort of legislates new gas, at this stage you can use as much reclaimed gas as you like.
Yeah.
Ding, ding, ding. And so everything kind of becomes clear in terms of why we decided to do this, because we kind of saw it coming. We saw that actually a reverse of the wave, because it was a line that was going down, and say, okay, how do we remain competitive in this environment? And so the idea of how do we make sure that we have that constant stream of reclaimed refrigerant, and that's where sort of the conversation started and the partnership expanded. But yes, as you were saying, if you install systems today and you use, let's call it a high GWP, the likes of R410A, the last thing that you want to happen is that for that system to have to be, I don't know, ripped out in 3-4 years just because there is let's say, a limit on the availability of a certain refrigerant.
Yeah, it's counterintuitive to what you're trying to achieve by phasing out those refrigerants. Because
that's again, a great way of saying it.
Yeah, the cost then of installing and the raw materials needed to build that equipment. Yeah, and plus then you've got to get rid of the old equipment. It just doesn't make any sense. So if you can prolong the life of these systems, the problem comes when you have product leaving the system.
Mm-hmm.
Yeah, as soon as the product enters atmosphere, that's when it's a problem.
Yeah.
If it's maintained correctly, yeah, people take responsibility for this is my equipment, I need to maintain it, I need to make sure there's no leaks. If there are leaks, I need to make sure.
And I guess that's a very good point, because I think sometimes, I don't know, maybe it's just me or because I get too involved all the time with this kind of conversation, and sometimes you sort of take something for granted. But like, you're right, everything is written and everything is regulated as if we were running open cylinders, pretty much.
So I think they still think it's the Wild West where they used to cut pipes. So that was a problem, yeah. That was a major problem. So that doesn't happen anymore.
No.
Shouldn't happen anymore. So I think now systems are a lot more, the way they're built, developed, manufactured, they're a lot more safety conscious and leak proof. So we say we've discussed these new R32 systems.
Yeah.
They're probably not so new now. This was a couple of years ago when we were looking at these.
Still, in the grand scheme of things, let's call them new still.
Yeah, the amount of solenoid valves you've got, isolation valves in those systems now is tenfold of what's in a standard HFC system.
Yeah, absolutely. And I mean, that opens an even sort of bigger can of worms in terms of all the things they need to do with certain refrigerant. But certainly from our point of view, over the last, I want to say 15 years at least, we started to develop and integrate even more and more devices and logic and software to immediately be able to recognize, are we leaking refrigerant somewhere, to be able to immediately notify someone that can then take action, fix the problem. Because again, fundamentally, if things were to always go in the way that they should, as in system comes on site, it's all piped in together, turned on, properly sort of serviced and maintained over the years, we have zero problem. Because essentially, as long as the refrigerant stays where it's supposed to be,
yeah,
that's fine. Happy days. But as you said, we know that there are still ways to improve, and therefore we are then sort of subject from this point of view to this level of legislation, which honestly, I don't really see them also like too draconian in a sense. I see where the European Union is coming from, and to a certain degree is also helpful to have a common direction, so all manufacturers can also come around a virtual table, shall we say, and be able to say, well, I know that I can advance and I should advance technology in a certain way. There's a clear direction, so I can also, from a manufacturer point of view, that deals with big old factories with big sort of manufacturing line. It's also good for us to say, no matter how restricted it is, but at least it's a clear direction.
Yeah.
So then I can plan accordingly. I can make sure that all my research and development happens in the time that it needs to happen with the right amount of lead time. I can plan the transition. I can plan the transition with the market, because I was chatting with one of our customers the other day, because we'll talk about it in a second, but we're already starting to look at maybe some of the newer refrigerant and some of the new things that might coming down the line. One of them being CO2, for example. And we were saying, well, the actual need for the refrigerant might not be here for another 7-8 years or so. But if we don't start talk about it now, we'll never be ready.
Yeah.
Not just us as a manufacturer, but also the rest of the industry that needs to adapt to, well, it's a new refrigerant and we need to deal in a different way. And it's very simple, like just looking up R32, we still haven't 100% completed the transition away from 410A into R32, but we started pretty much a decade ago with the first systems. So we know that it takes time, and conversation like this one is also very much a prompt for the rest of the industry to know that things are changing, new things are coming. How can we all adapt to work in this way?
And as you say, they're not doing such a harsh. You can't use these refrigerants anymore. No. They are trying to help. Obviously, the guidance is coming in, and they're trying to say, right, okay, we're going to gradually allow people to transition, because again, the cost. You think a small business, the cost is going to hit them hard if they were like, oh, I need to scrap all of this,
absolutely,
and start again from scratch. So,
and very much from an environmental point of view, as you were saying, there's also consideration of, okay, if I need to rip out a physical piece of equipment, then I need to do something with it.
Yeah.
And considering that we've seen clear example of systems that have been up and running for 30 years without any problem. They've been properly maintained, properly serviced, and they run like clockworks. Mm-hmm. So they are meant to be used, not abused, but definitely used, and used for quite a long amount of time. And therefore, it's important that provision like these ones are in place to allow that to continue as an element for the future.
The other thing is the supply of these replacement refrigerants.
Mm-hmm.
So YF at the minute you can get hold of. And it's quite an abundant. We can get a decent amount of it on the market.
Yeah.
You can get hold of YF. ZE is becoming more popular.
Yeah.
Slightly hard to get your hands on. They got these blends, so we were chatting earlier, 454C.
Yeah.
452B. So these are the new very low GWP alternatives to R32.
Yeah.
R32 is a lower GWP, I think, than both of those. And obviously we were discussing blends, because obviously those two are blends. So you've now got to source two different types of refrigerant.
Mm-hmm.
You've got to have the facility then. So a manufacturer, I don't know how many people are manufacturing these types of gases already. So
I think it's, as with everything, is going to improve. But yeah, you're right. It's
and these gases, they're not cheap either.
Oh, no.
So you look at some of these HFCs, they're a lot cheaper than, if you especially get reclaim, but there's no quota attached on there. There's no quota cost attached to that refrigerant. Yeah, if you then import, if I was a contractor now and I had a one system 134A, it's been installed for 10 years, lifespan's 20 years. Yeah, I would think, right, I'm going to start buying reclaim, use reclaim for the 10 years, save on that quota that I would have been spending on that, because you'd have a save in there.
Yeah,
because it would be cheaper for them to buy reclaimed, because there's no quota then attached to that reclaimed. So the money that they save for that can then be used for quota to purchase HFO blends.
Yeah.
Yeah. Which again is lower GWP anyway, so the quota will be a lot lower. But I'm assuming quota incrementally now is going to start increasing in price as demand goes up.
I mean, yeah, you're not wrong. We've seen an example, because of course the other thing that we probably should mention in terms of how this phase down and all this quota management works is that there are periodically, it's not like a straight line that goes down suddenly, but it's more of like, used to be gentler as a curve. It's become a bit more, slightly more harsh. Yeah. There's a recent, but it's still sort of a curve where every couple of years, roughly, there is a jump down to the next step. And what we've seen in the past is that as soon as you start approaching that jump, essentially market does what market does best. So you start to certainly see a bit of a speculation, shall we say, in some of these prices, because someone said, well, maybe there's going to be an even increased artificial limit in terms of availability, and who knows, and let's just put up the prices.
This is if you switch to reclaim,
that's it.
You don't have to worry too much about the price should stay more
constant.
Yeah.
And also, like, one of the other reason why as Daikin we decided to start this partnership and be able to offer the service was really looking forward and looking at the big picture in terms of saying, yes, we knew that the quota was coming. So we knew that it was going to be potentially challenging to say, I'm going to stick with just virgin gas, full stop. But also, the other thing that always sort of form part of the conversation is the idea that, again, from a European Union directly, they are massively pushing for decarbonizations of the building environment, meaning you rip out gas boilers and you put heat pumps. And I'm using heat pumps in a very generic terms in terms of just the basic technology. And based on the quota that they traced and the theoretical number of heat pumps that we should install from now to 2050 to reach those objectives, if we were to just stay on virgin gas, very clearly there wouldn't be enough refrigerant to go around to support that massive rapid expansion. Doesn't matter what GWP you want to go for as low as possible, but still physically there would not be enough. So it has a double importance for us to make sure that we can have that constant stream of refrigerant coming back, not just to us, but coming back to the industry. Because fundamentally, at the end of the day, one of the other reasons why we decided to start this service as Daikin was to do that education piece, that communication piece of saying, yes, there is a service that's going to make your life easier, but also realize that the service is very much there in service of the entire industry at large to make sure that HVAC as a competence can remain sustainable, can remain popular, can support that desire for massive growth that we see.
And that's it. And again, Daikin are massive in the space. Yeah.
We like to think.
Yes. Same with A-Gas. Do you know what I mean? It's the industry. Most people have heard of both companies. So if you see two relatively large players in the space actively trying to contribute to the environmental circular economy, obviously our goal's very synergistic. Yeah, we both want the same thing. We're both trying to achieve the same thing. So
absolutely. We must be doing something right. Yes, that's where.
But at some point it is going to be it's contract. Everyone wants to do the right thing. Mm-hmm. Yeah, they've all got the companies. They'll say, "Oh, I've got net zero targets." Obviously, that's a massive thing. Yeah, they need to make sure they hit their net zero targets. As I said, if they have a massive leak on a system, that's going to massively reduce the chance of you successfully achieving your net zero goals.
Absolutely.
So again, we've had cases where I've had customers ring me up, late in the evening. Our system's leaking. This is leaking quickly. Yeah, there's a lot of gas coming out. Can you get someone there in the next half hour, 40 minutes to come and recover the gas?
Yeah. And I mean, to be fair, it's definitely better nowadays. Like, again, compared to when we started, it was more a case of why would I need to worry about this? And
I said the knowledge is better.
Yeah,
exactly. You've got access to more knowledge. Yeah. And again, when you've got large players in the space actively, like you actively promote, reclaim your refrigerant.
And that really was the point for us, was how do we make it easier to communicate the message while sort of helping the industry grow together. And at the same time, we also see more people doing their own recovery job.
Yeah.
Because now they understand, okay, there's value, both financial value, but also environmental value in making sure that this action is completed in time, is completed in the right way. And so for us, it's very much a case of saying, well, mission accomplished in a sense, because now we see that really the industry is taken on board the concept, is taken on board the idea, it's making its own, and it's driving. And now we, if anything, we just get even more in-depth questions in terms of follow-up, in terms of, okay, so now you recycle it, but now you need to tell me exactly what's happening to the refrigerant once it's reclaimed. It's not just enough saying, yes, we've done it, but how we did it, what happened next, where is it going next? Because at the end of the day, as you were saying, more and more companies, they are now reporting on their ESG. So they need to report everything that is related to the environmental value, and all of their partners at the end of the day, whatever they do reflects on their overall score. So they are always more and more invested. But speaking of what happened to the refrigerant, I wonder if we can have a bit of a look, shall we say, behind the curtains in terms of what happens to some of the refrigerant. Because we do get this question quite a lot in terms of saying, I understand the visible part of the service. Like the visible part of the service that we discuss is I give someone at Daikin a call, send them an email, book an appointment. Then we have someone from the lovely A-Gas team that shows up on site with their equipment. But can you walk me through the less visible part of the service? So your team, one of your teams arrive on sites, plant their machines there, start to do the recovery process. Then what happens next?
So I said all the engineers are experienced enough to know they get sent to various different sites. So typically customers call us out if it's a job they don't want to do themselves because it's very difficult to access or it's a lot of gas and it's going to take them days and days to do it. We can come and do it in best part of a morning potentially. So,
because I guess we should also say that the type of machine that you use are on a completely different scale compared to what, let's call it, a regular end user would be able to access and
the trick for speed of recovery is how quickly can you condense the product.
Okay.
So obviously, how much throughput can you get through the pipework?
Yep.
Yeah. So obviously, the connection onto the system, got a 1/2 inch, great. Yeah. So the quicker you can get it out, and also how quickly can you condense the refrigerant in the outlet cylinder?
Okay.
So you're trying to get gas through a system and then condense, so the pressure of that outlet cylinder is as low as possible. So that's the trick to it.
Yeah.
Yeah.
You make it sound so easy.
Yes. Everyone's going to do this now. I actually do a bigger condenser. So yeah, the gas then is recovered into cylinders or drums or whatever vessel we're using.
Mm-hmm.
It's returned to A-Gas either by a courier or the engineer themselves, because they're obviously in their own vans. The gas comes back to A-Gas. It's weighed. So they weigh the cylinder. They analyze the cylinder. So they have a little syringe. They take a sample.
So all of these happens in your facility in Bristol, right?
Yeah, all the refrigerant comes back to Portbury. So it'll all come back deemed as waste.
Right.
Yeah, so you've got a difference between recover refrigerant and reclaim refrigerant. The refrigerant we've got is reclaimed. Mm-hmm. So that straight away that is waste.
So as soon as it comes out of the system, before, I guess, because we like to think we know what's in there, but until someone actually does the analysis, there might be a chance of something else might be present as well.
Contractors are guilty of, they just top systems up. Yeah, so they might have an R22 system. Yeah, and there's still some dregs of R22 in there, and they've just topped it up with some 134A or whatever they've used to replace it 404. Yeah, so then when we end up taking the gas out, they say, "Oh, it's 100% 404." Oh, yeah, there's 15% R22 in there. Yeah, because they don't know who's been servicing it or if they put the correct gas in. So the data plate you can't take for face value.
Yeah,
the gas comes back analyzed. On a GC gas chromatography.
Okay.
So they inject that into there, and then it gives you peaks and troughs, and it shows basically there's this percentage of a particular gas. Yeah. So it breaks it down into individual. So if you've got a blend, it'll tell you exactly the spec of. So 410A is 50-50, 125 and R32.
Yeah.
Comes back, it might be 70-30.
Okay.
Yeah. So you might have lost more 125s, higher pressure than the 32. So if they had a leak, you're more likely to get the R125 vent off.
Right.
So then obviously then the spec of that refrigerant is now out. So in terms of efficiency of the system it's running, potentially now they should have replaced the refrigerant or swapped a new.
Yeah. So the analysis is done on each cylinders?
Every cylinder, every single cylinder, yeah. And then it's streamlined then from that point. So if it's above a certain purity, so they say, it's 410A, but it's out of spec. Yeah, there's only 125 and R32 in there. There's no 600A in there or 134A. No, there's no other contaminant in there.
It's just
out of spec.
Maybe slightly out of balance. Yes.
So that the ratio of refrigerant isn't correct. Yeah. So that'll be streamed as a 410A. It'll be batched.
When you say stream, what do you mean?
So it's just it's just repalletized. So they've just segregated it out into whichever.
So
gas
essentially, you know that it's not contaminated. So I guess it would follow then a separate process.
So at this point, we obviously don't know if there's any gas, moisture, non-condensables in there, or if it's acidic, or there can be loads of nasties in there, be oil in there. Mm-hmm. If it's too contaminated, so say someone's had a system, they put 4 different types of refrigerants in it.
Nice.
Yeah, they haven't looked after it properly, they haven't backed it out after use, and you've got this cocktail of different refrigerants.
Yeah,
that's then streamed as cocktails waste.
Okay.
So that's more.
Is there anything that can be done with that? Or
Yeah, so that's obviously slightly trickier to separate.
Mm-hmm.
So you've got azeotropic blends and zeotropic blends. So any azeotropic blend they can't be separated.
Right.
You know, it's very difficult to separate those refrigerants. So you look at 134A-YF, they have very similar properties. It's very difficult, they're very sticky.
Mm-hmm.
So it's very difficult to get them separated.
Right.
So if someone, say we go and recover from car ACs or car scrappage companies, they typically have 134A-YF blends because that's what's in their cars. Yeah. So they add the 134A to reduce the flammability of the YF to put it in a vehicle. So we'll go back to the process of you've streamed each refrigerant type.
Yep.
It's then bulked up into an ISO or a static tank that we've got.
Essentially just a bigger container, right?
Yeah. So, the cylinders are decanted.
Yeah.
They're decanted into drums.
Just trying to form a picture for someone that may never seen or heard this topic. The gas would come out in a lot of essentially smaller cylinders and smaller containers, and then based on what it is, you aggregate it together so that it's processed in a larger batch.
So then it'll be processed that'll be purged of any air, any non-condensable gases will be purged.
Right.
So that purge cycle can vary in time, depends how much gas is in the cylinder and what type of gas it is. It'll go through a clean-in rig, which removes any moisture and any oil.
Mm-hmm.
So obviously refrigerant you can boil off, and then the oil will stay in this little still.
Right.
So it boils off, siphon it off the top, but then it goes back into a clean drum. So now you've got
like a distillery kind of.
Yeah, so you've still got out a spec refrigerant.
Yeah.
But it's now had the moisture, non-condensables, and the oil removed.
Right. So you're down to more basic chemistry.
Yeah. So now we just need to separate the gases or add.
Yeah.
Yeah. So add more of one particular type of the blend. So if it's low on 125, we would then add some more 125 to bring it back into spec.
Okay, so we've gone through the steps. So we are now at the other end. What is there anything else, or let's say what is needed to then essentially be able to put a label on a new cylinder saying this is now fully reclaimed R410A, shall we say?
So once it's all been separated out and we've streamed it off and it's separate, so it'll go to separate vessels. They're then reanalyzed.
Okay.
Yeah, so they go through our lab then, and the lab basically sign off purity, moisture, oil, make sure it's AHRI 700 standard. It's got to meet that spec.
Okay, so there is an international standard
So
minimum to.
I can't remember what it is. I think it's the American heating.
That's
something.
But there is a standard. Essentially, there is a benchmark that says
which is equivalent to Virgin.
To a certain
so that's what Virgin should meet. The standards Virgin material should.
Okay.
So we hit that. If it doesn't pass those tests, it goes back in. Has to be reprocessed again.
Right.
But 9 times out of 10, it comes out as we want it to come out. So that's reanalyzed, and then we basically then down pack into cylinders or drums or whatever customer demand is.
Yeah.
And then ship back out.
Fair enough.
So again, for us, we want the reclaim material.
Mm-hmm.
Yeah, the reclaim material is our bread and butter, really. It's how you stay competitive. So anyone who's just dealing with virgin material now, supplying virgin, and they're going to miss the reclaim, they're going to try and move straight to HFOs. You're going to struggle on cost, just competing with cost. Manufacturing cost.
Yeah.
Because a lot of these refrigerants are imported anyway.
That's also a very good point.
So you gotta look at. That's why we supply some of the largest wholesalers, because we can be quite competitive on price.
That's great. Now, one of the other questions that sometimes we get, but also in general, while we're talking about refrigerant, is do you see a big difference in terms of handling non-flammable versus flammable refrigerant? Like the classic example of saying handling 410A or handling R32.
Yeah, so it's crazy how much legislation there is in place, health and safety wise, for even just an A2L.
Which is good.
Yeah, it's got to be there. Yeah, you don't want anyone getting injured or anything like that. But it is crazy how seriously people take flammable refrigerants. Yeah, the industry is very hot on, well, it's flammable, you need to abide by all the ATEX laws. Just doing a basic recovery now, if we want to go and recover one of your splits, a couple of kilos of R32, that now involves specialized equipment, all ATEX zoned equipment, certified equipment, vac pump.
So your machines are also essentially physically different to be able to handle R32.
Yeah. But it's the same with you in it now. You've made new systems which can handle flammable. It's probably cost a lot more because ATEX equipment just costs a lot more than standard.
Yeah.
So there's a cost associated with it, which again comes down to the industry having that transition because the cost is so high to move to just pure flammable.
Yeah.
That it's just not feasible for many businesses or many companies to just make that switch straight away.
Yeah, no, fair enough. It's like what we've been discussing so far. It's making sure that everybody's on board with the message and progressively can move and can shift.
100%. It's more common now. We're getting a lot more requests for flammable refrigerant to be recovered.
And I guess that's also why the good part of partnering with someone like you that knows everything there is to know in terms of refrigerants, that you've got the knowledge, the know-how, the equipment to be able to deal with this kind of, again, quote unquote, new refrigerant, shall we say, to begin with it, to essentially show the way in terms of this is how they should be done. I guess logically, let's say, with putting sort of a market cap on it, the idea of saying, well, Fortinet system will be phased out more and more, so there will be less demand even for reclaimed R-Fortinet. R32 systems are now predominant. They will become even more in the next few years. I guess it makes sense to look at other creative way of say, where else can we get R32 from, essentially. And once you realize that we've been essentially using R32 in disguise for the last 20 odd years in terms of Fortinet.
Yeah.
But again, I wasn't sure from a commercial viability point of view if that made sense already at this point to say, well, let's break it apart and just use what we need and use the other stuff.
Most of the refrigerants can be separated and streamlined, but you get the odd one that, so if it's azeotropic, then it's very difficult to separate.
Yeah.
So
that's good. And I guess, again, sort of reinforces the idea of why we are here having this conversation, but also why we are here in this partnership, because of your know-how in dealing with refrigerant. There's a lot of value that we can then give back to the market in terms of physical value in terms of refrigerant, but also, again, education, conversations, and making sure that the right upskill can happen. So we are almost running out of time, so let's get to our final thoughts for the day. As we were kind of alluding toward the beginning, we offer this specific service in partnership, but you also essentially have a similar service that you offer directly. Is there anything else that you would like our listener to know in terms of what A-Gas can do in the UK market?
So I would definitely say either reach out to myself on LinkedIn
and we'll put all the links in the descriptions and all the contacts.
Or email A-Gas directly, just go on the website. But I say we're doing a lot of work for data centers and larger companies, but that doesn't mean to say we'll do any type of job. So don't think, I've got one heat pump, I'm not going to ring A-Gas to come and do it. Yeah, we'll come out for any size of refrigerant charge.
Yeah,
I said they're very inexpensive for what we're offering. Yeah, so it's
good to know.
Yeah, so if you go through Daikin as well, it's obviously a lot more favourable. But no, definitely don't be put off just because you don't think there's enough volume there, or if it's not something you're comfortable doing yourself. Yeah, definitely reach out and give us a call. Or
wonderful.
So we're taking people all the time. We are very busy at the minute, but we'll try and squeeze you in as best we can. It's Daikin, it is. They just keep our calendar busy. It's all the Daikin customers.
Sorry about that.
Yeah.
Any other place that you would like to send our listener to, or just your website would be the right place to go? Yeah,
just the website, or say it on LinkedIn. Even if you reach out to someone at Daikin, they can point you in the right direction. I don't think there's anything on the website with A-Gas. Might not be. Maybe at the bottom of the partnership.
We do have plenty. And again, we'll put all the links in the descriptions.
Yeah.
So you can find all the relevant things. Well, thank you very much for the conversation today. I think it was.
Hope it's been good.
No, it was really good. Fascinating as well to look a bit, sort of peek a bit behind the curtains. As I said, it's something that we get asked quite a lot.
Yeah.
And I think it was nice to just give a bit more of an insight of actually what happens in reality to this refrigerant. Because going back to full circle to the very beginning, as we said, it's everywhere. It's sometimes actually more often than not given for granted. So hopefully after this conversation, people can start to realize a bit more the value of the actual materials and sort of start to treat it with the right respect they deserve in that sense.
Yeah.
So again, Jake Matthews, thank you very much for joining me today. And once again, we'll find all the links in the descriptions for all the information and where to go if you want to book the service, if you just want to learn more about what A-Gas and Daikin can do with refrigerant. But till the next one, it's been a pleasure having you today. I'm Matteo Dell'Ombra again for Daikin. Take care. Bye-bye.